Hello, let's do 3 sum. I did 2 sum a couple of days ago. I'm hoping I can explain a little bit better. We're trying to find 3 numbers within this array that they give us that when you sum them up equal to 0. They can be the same number, but the indices have to be different. I does not equal to j, I does not equal to k, and j does not equal to k. So we want to find all possible combinations that give us a sum of 0. We can't have duplicate triplets, so we can't just return another one of these, but in a different order. Oh, but it looks like we're not supposed to return the indices, but the actual values themselves. So how do we do this? Let's try a brute force approach. Maybe do an n cubed loop through the nums, which would be something like for I, for j, for k, for j in I plus 1 to n, and k equal to j plus 1 to n, I equals 0 to n. Actually, all of these should go to minus 1, at least. This one should go to minus 1 is the end, but then I subtract 2, so that this is minus 3. So then this has room to go to minus 2, and this has room to go to minus 1. If this plus this is equal to 0, then add it to the answer or something like that. So answer will push back, blah blah blah. Right, so that sort of works, but the nums length is up to 3000, so that'll be 3000 cubed, which is definitely too much. And also it doesn't take care of duplicate values. How do we take care of duplicate values in this case? We could have instead of while loop, when we increment, we just want to keep incrementing until we get a different number. It's not fast enough anyway. So how do we actually do this? Well, if you know this two-sum approach, there was 2 ways of doing it. There was the hash map, but there's also the 2-pointer approach. And the 2-pointer approach is can be essentially be applied to this inner loop here, which can be done in linear time. So it'll be n squared instead. That would be faster. So the 2-pointer can be applied to these nested loops, the 2 nested loops. First, what we can do is actually sort it, because I don't think it's a sorted array, so I need to sort it first, because 2-pointer relies on it being sorted. So while I is less than j, well, actually let's do jk, and start j at equal to I plus 1, and k at equal to k plus n minus 1 to the very end. And then it's like, if the sum so far is a bit larger than we want, then we want to decrease k, of course. If it's a bit lower than we want, that means if it's less than 0, then we want to increase j. Potentially keep going, because there could be more combinations given the same I, that the numbers at I, j, and k are equal to 0. Yeah, it's a bit complicated, this one. Best way is to go through an example like this. So we'll start I here, and we have j here, and k here. So that's the initial setup. But before we do it, actually, we have to sort it. So we have to be minus 1, 0, 1, 2. Okay, so we find the sum of I, j, and k, which is minus 3. We see that's less than 0. That's less than what we want, so we increment j. We can increment j while it's still equal to minus 1. So now we have 0. Then we add up the sums again, so minus 2. It's a bit higher, but it's still less than 0, so we have to increment j again. Then we have minus 4 plus 3, so it's minus 1. Still too much. And then I increment j. But then j and k are equal. I will break out of the loop, so there's no solution where I is equal to minus 4. And then I move I up, start j1 over here, and repeat. So I can go, if does this equal to 0? Yes, it does. So minus 1 plus 2 is 0. And so push this to the answer. We have a minus 1, 2. If we find an answer, increase j. And then k will naturally decrease afterwards. So you have minus 1, 0, 2. That's greater than 0, so we have to decrease k. Minus 1, 0, 1. Yep. So that's 1. That's another answer. So you have minus 1, 0, 1 is equal to 0. That's the other one. And then I could either decrease j or increase j. Let's just increase j. And they're equal, so I break out of the loop and I increment this one while it's equal to minus 1. So that means I'll go all the way up to 0 and start j and k like this. Does this equal to 0? No. And because that's the end of all the loops, then the whole thing breaks. I mean, the whole thing kind of exits, and then I return this answer. Yeah, so that's the general idea. So we have to have a while loops. I, j, k, and say I is equal to 0, Well, I is less than nums.size. Actually, we should probably say n is equal to nums.size. And then we could say, well, I is less than n minus 2. If n is equal to n minus 3, then j could be equal to n minus 2, and k could be equal to n minus 1, which is fine. And then I set j is equal to I plus 1, and k is equal to n minus 1, while j is less than k. Keep looping. And I know here I need to say current I is equal to nums at I. And then while current I is equal to nums at I, undo plus I. Keep incrementing I while it's the same value as before. Here I need to grab the sum. So the sum is equal to the nums at I plus nums at j plus nums at k. Now if sum is equal to 0, that means I want to add to the answer somewhere. Int answer is a vector of vectors ints. And then we could say answer dot pushback nums I, nums j, and nums k. And then here we could say if here we want to increment j if the sum is less than 0, because then if increment j in a sorted array, that will increase the sum. So if sum is less than or equal to 0, I actually want to increment j. So say int current j is equal to nums at j, and then basically the same as this. While current j is equal to nums at j, increment j. Okay, there is a slight problem. What if the whole array is the same number? At some point I will be equal to the last number, while j is less than n minus 1. Okay, no, that works. And then also else, I want to say the same thing. Nice. Also here I have to say while I is less than, while I is less than n, because at some point I will increase beyond n minus 2 and I'll break anyways. And then at the end, I could just return the answer. Uh-oh, what happened here? Oh, this should be minus. Decrement that. The reason why is because I forgot to sort it. So sort. Oh, because I'm decreasing k. I have to go while k is greater than or equal to than j. Keep decrementing it. In fact, here I can say while j is less than k. There we go. Nice. Okay, let's give that a go now. Hopefully that works this time. Well, there's another error. Nice.